So thanks for coming. This is the third of our virtual Energy and Environment Forum events for the semester, and we may be starting to finally hit our stride here a little bit after figuring out how to do these things online and still be able to have a kind of fun and engaging question and answer afterwards. If this is your first time coming, welcome. This is our effort to put together an opportunity for different researchers from different disciplines to talk about energy and environmental topics. It's something we don't get to do a lot. We're typically talking to people within our disciplines, which sort of gives us kind of a specific framing on different questions and issues. And this is a nice chance to see how other people approach it and the tools that they use. If you like what you see here today, we have two more events on the calendar for fall, both of which will be online in the same format you're seeing here. On November 5th, we will have Robert Johnston from Clark University. Rob is an economist. He will be talking about using meta-analysis to quantify ecosystem service values. So I know lots of us in here have talked and used the term ecosystem service values or ecosystem service valuation. Tune in there for you to get a perspective on that from an economist. On November 12th, we will have Tara Conkling. Tara is with USGS. She is in their Forest and Rangeland Ecosystem Science Center. And I don't have a topic from her yet, but you can imagine kind of what she will be talking about if she's coming out of that group. I think that's it. So with that, I'll hand it over to our very own Paul Armsworth to introduce our speaker for today. Oh, one more thing before Paul goes. So everybody, for question and answers, if you'll just type those into the comment box or the chat box here, and then I will save those and collate those and feed those to Christoph at the end of the presentation. Paul, all of you.
So good afternoon, folks. Great to see people pouring in. You guys can't see, I've got the participant up so I can see kind of the counter climbing as more join us. So great to see everybody this afternoon. For me, this is like the perfect treat. I don't have to do any of the work, and yet I get to do one of the most fulfilling things in academia, which is I get to celebrate a colleague who is a really good friend and a dearly valued scientific collaborator. And awesome. It's one of the best things we ever get to do. So I want to introduce today's speaker to you. Right? So today's speaker is Christoph Nolte. Christoph is an assistant professor at Boston University, where he's in the Department of Earth and the Environment. You might wonder what that leaves out, but you know, we have academics who work on Mars, but Earth and Environment, just to pin it down for us. Christoph joined Boston after his postdoc at Stanford University in the School of Earth Sciences. He did his training, he started out his training in Germany, where he did his bachelor's and his master's before doing his PhD at University of Michigan. Christoph's research looks at the efficacy of land conservation. So where are we being more effective? What could we do to improve our efforts? It's scholarship's been published in PNAS, Nature Climate Change, many other journals. It's highly influential work, and I'm going to place a bet for you now. So I know land conservation writings pretty well. I'll place a bet for you that Christoph's work not only is influential now, it's going to be a lot more influential moving forward as well. And in this material you're going to see today, you'll see why I say that. You'll see the potential in what you're going to get presented. Christoph has worked all over the world, right? I barely speak English. He speaks rafts of languages and has worked in many, many different countries. He has large current projects, and you might see a bit of both today in Colombia, as well as here in the US, looking at land conservation. The hardest thing when introducing Christoph is to say, what is he? Right? Like the very best of interdisciplinarians, Christoph doesn't fit in any of our brackets. Right? Some would say he's an environmental economist. Maybe. Public policy guy. Conservation scientist. Yes, because we take in all kinds of different things. I think the best description for you is that Christoph is a spatial data scientist, someone who is harnessing the power of big data resources to try to improve and advance the cause of conservation. Please join me in welcoming Christoph Nolte.
Thanks so much for this formidable introduction, Paul. It's an absolute pleasure to be here. Thank you for having me. And thanks to all of those who are tuning in. It's a weird time. We're sitting in our COVID caves and we're learning new modalities about interacting with each other. So because I see 58 people on the participant list, I am curious about you. And so let's start with something that both helps me to learn something about you and that also shows me how well versed you are with Zoom. Here goes. I am posting a link in the chat. If you follow that link, you will come to a poll that I have for you that contains my favorite question. And I will share the screen so you can all see that poll. Share my screen. Talking about being well versed with Zoom, and now I cannot share my screen. Where should it be popping up? Oh, I cannot share my. Oh, I can share my screen. Okay, there you go. All right, here you go. There's a link up here that you can follow, and if you're able to follow this link, you might help me answer whether and to which extent you chose your career path because you wanted to make a positive difference for the environment. And I see the numbers are turning into uneven numbers, which means that quite a few people have already participated. Now here's another question. If after having gone as far into your career as you have, and you still want to make a positive difference for the environment, then raise your hand in the participant list. You click on participant list and then you raise your hand. And then I see that you still want to make a difference. And now I'm seeing people, lots of people pop up. Wonderful. Last question. If you are actually wondering still about how to make that difference, and in spite of all you've learned, you're still not quite sure, unmute yourself and make a very short sound like, huh. Wonderful. Thanks so much. So this is obviously a question that I like to ask to audiences that are working on environmental issues. Most of us get into this field because we want to make a difference. And then depending on your career path, you might have had some of the following experiences. You say, okay, where do I learn how to make a difference? Well, let's go to the university. Let's ask the people who are supposed to know, the professors. Right? That's probably a good start. And then if you have, once you're finished, you might go out and see, well, the world is actually very different than the models that professors had in mind. And many of the things that you learn don't really seem to match up with the real world. And then you start going back to the university and back to the science and back to the reality and start going back and forth in order to, build essentially your own knowledge of what makes a difference. And if you do this for long enough, and this is why I think it's so interesting to hear Paul's description that it's so hard to describe what you're doing. If you do this long enough, then you become a person who is asking that question. And what I'm here today to share with you is one, the information that there are actually jobs for people who just ask that question. And that we have better opportunities to ask that question today than ever before. And so what I want to share today are three nuggets, I think, three areas of research that I'm really particularly excited about because I feel these are the cutting edges of work that's happening right now that helps me, that helps you, that helps all of us to try to make sense of the world in a way that we never could before. So it's a really interesting time to do that, and I'm glad that these are topics that you also seem to be interested in. All right, let's start. Has anyone recently heard good news about parties in the US coming together, voting together on something that really feels good? If not, you might have missed this one. August this year, Media from both sides of the aisle, as you might say, celebrate the bipartisan bill that for the first time since 1964 fully funds the Land and Water Conservation Fund, which will make available over the next 5 years $900 million per year for more land conservation. That's $4.5 billion. That's a lot of money. That's historic. How can we put this into context? How much is that if we think about what needs to be achieved? And how will we know where to put that money to make the biggest difference for the things we care about? The longer that you're in the field, the more you will realize there are many, many organizations that try to make a difference, right? Besides the governments, obviously, those who have power and those who have money, there are convening organizations. There are NGOs, some of which you might know because they rely on donations, so they are very visible to you. You have advocacy organizations, you have large donors, some of which are bilateral and government funded, some of which are privately funded. You have information organizations, you have think tanks, so many different organizations working in the field of conservation and all claiming to make a difference. And with that comes a rise of ideas of how to make a difference. Right, so briefly, if I say that, you know, people actually end up paying you for this kind of, asking this kind of question, I just want to mention my own relationships with some of those organizations. For transparency, I did my PhD in collaboration with the KfW, the German development bank, who finances a lot of conservation around the world. I did a few consultancies last summer and the one before for the Inter-American Development Bank, also an impact evaluation. This summer, I worked with the Nature Conservancy, the strategic branch, to try to figure out how they can use those methods to assess their impact. And I'm on the expert panel now of the Gordon and Betty Moore Foundation, which is to assess the impact of their Andes Amazon Conservation Initiative, which financed which put about $500 million into conservation. So, so there are lots of organizations that are removed from reality in the sense that they are not in the field doing all of that work, but they still wonder, like, how can we make the difference? So you see a lot of different interventions that people do. People create parks, people buy land, people trade lands, people create rules on top of land, either impose them or voluntarily trade them. You can create concessions, community forests, there are biosphere reserves, there's advocacy, there are collaborations with indigenous lands to protect their lands, there are integrated conservation development projects, there are many, many interventions that people spend money and effort on and advocate as being the solution for your problem that, you will learn about as you go into this field. And so one question that seems to be relevant to ask here is, what difference does it make? And I think the best answer is try to see for yourself. We have now more photos, more pictures of the planet than we have ever had before. I don't need to get into the detail about the data revolution. You are fully aware that we're in a very, very special time. What you might not know is, satellites have been around the globe for a very long time. What you see here is the time lapse of Google's Earth engine, which aggregates satellite data from the Landsat, mostly the Landsat archive since 1984. And it is a video of 4 terapixels that will allow you to see how the world has been changing over the last 30, 40 years. Today, that would look very different, much higher resolution, because at this point, every day we get pictures at 1 meter resolution of the globe. So the data amount is just mind-boggling. But we can look back in history. So you might have seen some of those videos before. You see how deforestation advanced into the Amazon. Here's a case of Rondonia. You can zoom into the Argentinian Chaco, which is another deforestation frontier that has been deforested very rapidly over the last 10 years or so. That gets a little bit less attention than the Amazon because it's not this great tropical forest. And so you might, well, one, you can see for yourself what's happening to the surface of the planet. But then how do you go from there to making inferences about interventions, about things that people have done and whether or not they have actually affected what you see on those satellite images. And so I want to introduce in this talk three pieces that I would like you to know about, because I feel these are interesting, emerging fields of research where there's currently very smart people, wonderful people, very friendly people usually working on, and that you might end up wanting to contribute to. So what are the two questions that we want to ask, that we want to know if we want to, let's say, allocate funding or effort to a conservation intervention? One, we want to know what is or what will be the causal impact of that intervention in that location. And two, what will it cost? If you know these two, you can put that into lots of different optimization algorithms and you get optimal solutions. And then you can take those to policymakers and see whether they want to talk with you or not. But to answer those questions, you need three things. One, you need to reliably observe the outcome of an intervention. Two, you need to create you need a plausible counterfactual. You need to be able to provide answers to the what if question. What would have happened if the intervention had not happened? And then two, you need a good idea of what it will actually cost. If you want to scale up an intervention, if you want to do it in certain locations that are more expensive or less expensive, how much will it cost? So you need good cost estimates in order to make those larger scale recommendations. And the advances that I see actively work with or work on are time series algorithms for detecting change in satellite data, land cover change in particular, quasi-experimental methods for causal inference, and then more recently, large-scale synthesis of rich property data in order to model the value of land and the cost of conservation. All right, so let's get through all so my intention is to give you a glimpse of all three of those that is sufficiently deep to get your mind working, the wheels turning in your head, and then we can later have a conversation around any of those. So the first part is one that I do not personally do as a researcher, but whose products I use. So I need to understand at least sufficiently about it to interpret the data. And that is the reliable outcome measures of land cover change through satellites. So you might be familiar with the location that we're looking at. This is Knoxville. And if you're familiar with the area, I don't know for how long you have been in Knoxville, but you see some locations, you see, you notice urban development in the Southwest. You notice perhaps that 3M created a plant. You notice perhaps that there's gravel extraction up here. But there's something else you might notice if you just zoom out and look at this entire picture and try to understand what changes. If you really try to, just as a human, not as a computer, as a human, to try to make sense of what's happening here, you might already notice it's kind of hard because the image is flickering. Why is it flickering? Well, because it's satellite imagery. Satellite imagery is a photo. A photo, what the photo produces depends on the angle of the sun, in which season you are, is there a drought, has there been a dry season, are there clouds or not, is there haze or not, etc., etc., etc. Satellite data is dirty data and it's hard to work with. So if you just took two images of two of those different time periods and try to put them into a classification algorithm and compare those two images against each other and infer change just from a two-image comparison, you can go very, very wrong. Even with a lot of care, you will still be, it's still quite challenging. So one really fascinating development that has happened over the last, I would say, 10 years, really with the first products only coming out 7 years ago, and really interesting work happening, is time series analysis to make sense of this data. So here's an example of a single pixel, of the values of a single pixel that has been observed with the same satellite over decades. And every single point you see here is one pixel value of one band of the band 5, of the infrared band of a Landsat pixel over the course of several years. And so the first thing that you notice is things go up and down a lot. Now, which of those is real change and which one isn't? this is a field of research that is currently actively being worked on. But here's one algorithm that I know particularly well because it's developed by people in our department and their collaborators around the country. And that is the continuous change detection and classification algorithm. What this algorithm does is that for every single pixel, it starts at the beginning, it starts fitting a model, which you can specify with some kind of sinusoidal or components to account for variation over time and seasonality. And it tries to predict what the pixel value that it should observe next. And then if it comes across several values that don't really seem to match the previous model, it says, well, okay, now we have 2 or 3 or 4 observations of something that's different. So something changed. So it breaks and starts fitting a new model. So you get time segments and you get model values, model parameters associated with those time segments. What you can then do is to use those model values, put them into a classification algorithm, such as the random forest or others, and create maps of change. That, well, the remote sensors would say, well, be careful with what you're saying here, but let's take this from a non-remote sensor. This removes many of the issues that you get if you just compare 2 images, even if those are composites. The classification is based on the model parameters, not on single pixel values. You can observe change in multiple classes, not only forest to non-forest, or like one whether it's there or not, but you can have 5 or 6 or 7 or 8 classes and observe change between them in a consistent way across the landscape. And because you get this model fit until the point that it breaks, you can have very fine temporal resolutions. So one thing where this turned out to be useful in an analysis that we did in Massachusetts is we observed those locations that had suddenly experienced change, like a loss of their forest cover at the same time that they were protected. And so we looked in the data and found all those golf courses that had created easements on them and also were then created as a golf course, which was something we wouldn't have been able to observe if this data had just existed for, let's say, 5-year or 10-year periods. So really interesting data. That data, there are many variations of this algorithm. Eric Bullock, one of my collaborators, has been developing a version of that algorithm that distinguishes between degradation and deforestation in tropical forests, which is great because degradation is something that's happening a lot, but so far we haven't been observing it because usually the forest cover closes really quickly after the disturbance. So with those algorithms, we can start mapping degradation and deforestation. And Eric Bullock has done that for the entire Amazon. The data is available, you can download it. And so those data sets are now becoming available and you can download them and just look at them. Just this year, LCMAP came out, a product by the USGS that uses a prior product, which is called the National Land Cover Database, and essentially maps it as a time series from 1985 to 2017. There are ongoing research projects at Boston University which try to take that to the global level for the entire, since the beginning of the century. The project is called GLANCE. Down there's a link that you can follow if you're interested. And these are just 2 examples that I'm familiar with of a large body of research that involves other research groups and other, many research groups in other universities. Some of those that are better known and that make their data more easily accessible are Hanson's research group at Maryland, and then the Land Trend Algorithm series by Kennedy at Oregon State University. But there are many more. The one thing that I would like to, so if there's one thing here that I want you to be just cognizant of is that those algorithms really make it much more nice to work with change data and to rely on that things that is mapped as change is also actually change. Things are still tricky in some locations. For example, one area where I have quite a history of working, not many publications yet, is Colombia. Colombia is a country that has one of the highest levels of species diversity, of threatened species diversity in the world, especially in the Andes. Colombia has had major investments into conservation, very unique ones. Since 1993, there has been a law that obliges all municipalities and all state governments to invest 1% of their income into land acquisition for conservation. There's no other country that has this kind of law, and we still don't know anything about what that law did. So ongoing research that we started this year, or let's say we did the previous work for the last 3 years, but finally we got funded with NASA, is looking at that, developing new ways of using these algorithms to map for changes in forest habitat and forest classes in this very, very species-rich, very complex and very difficult to map terrain. So stay tuned for that. We really hope that we can improve substantially over what's been done there before. And then we want to see whether we can understand what difference those land acquisitions made versus payments for environmental services. And that is work that is mostly moved forward by my PhD student, Anna de Boredo Segovia. All right, time series for satellite images. I'll stop here and get to the next topic. So if you have, let's say you can get to a reliable outcome measurement, you know whether and where in the world forest cover has been lost, forest has been degraded, grasslands have been turned into development, whatever your outcome variable is. Let's say you have solved that problem. Then what? What do you do with that data? If you want to make an argument about the causal impact of an intervention, you somehow, in some way, need to answer the what if question. What would have happened if the intervention had not happened? That is something that we do not observe. Obviously, we do not know exactly what that counterfactual outcome is. It has never happened. It has never occurred. It's not reality. But we have to make assumptions about what that is in order to make any argument about causal impact. Even if any claim that you make about a causal influence will usually, under the hood, have this idea of a counterfactual, even if you're not explicit about it. So how can we be more explicit about it? But first, why is it so important in conservation? Here's a good example. This is the Vale do Javari, a huge indigenous land in the Brazilian Amazon. It is massive. It is larger than the country of Austria. It is in the Brazilian Amazon, so it has massive carbon stocks. Now, you could say, well, we have protected this gigantic amount of carbon, but that's great. Can we get carbon credits for that? Well, carbon credits is something that should be paid for things that make a difference. This particular location, you can look at it through satellite imagery. You can prove, basically, that no forest has been lost since its creation in 2002. And today, so you can say, well, nothing has been lost. But the question is, how much would you have lost if it had not been protected? And there are few ways to go about that. And there's one way that it has become particularly popular in the last, I would say, decade, partially because it's easy to interpret. It's relatively easy to do, I would say. But there are a lot of important things under the hood that one needs to understand to be able to interpret and perhaps criticize that kind of method. And what I'm referring to here is a quasi-experimental method that is called matching. Matching starts it starts with the observation, with the unit. Let's say it might be a parcel, it might be a pixel, it might be a person that has received the intervention that you're interested in, a treatment group. And then you use an algorithm and extensive data on confounders to find the most similar parcel among those who has not received that intervention, but that was as similar as possible to the treatment group before the intervention even occurred. So this is called quasi-experimental because an experiment would be you randomly allocate who gets it. But random allocation is very rare in conservation intervention. So often we have to be brought in after the fact and have to figure it out after the fact. So this is a method that uses data on so-called confounders, that confounders technically are variables that are associated, that are correlated both with the likelihood of the treatment and with the outcome. Any variable that has that property is a confounder. And a matching analysis should at least control for the most important confounders. We will revisit those confounders in just a second, but I want to go through the method. So once you have created this artificial control group, you think you can make the assumptions that in the absence that those parcels were essentially the same, except for the fact that one received the intervention or not, and the other didn't, then you can say, well, the difference in the outcomes that we observe between those two locations, between those two units, between those two parcels or pixels, that we assume is the causal impact of the intervention. Right? And you do need to treat the results with a very substantial amount of suspicion. We'll get there. So let's go with 3 examples that I'm particularly familiar with because I did them. And the reason why I'm showing them is not to show off like my own research. Of course, that's the reason. No, because I actually can answer questions about this. So one of those analyses was an analysis in 2013 on the impact of protected areas in the Amazon. So the question was, which of those governance systems that exist in protected areas in the Amazon is associated with what seems to be the largest avoided deforestation? There are people that advocate for strict protection, parks, throw everyone out. There are others that say no, sustainable use. We have to have people, use rubber tapping and Brazil nuts and all other kinds of, and timber and all kinds of other ways to use the resource sustainably, but just prevent this large scale commercial deforestation. And there are many initiatives to give rights to indigenous people and as a side effect also conserve the forest. So which of those are more effective, or at least which of those are associated with what seems to be higher avoided deforestation? If you just look at the deforestation data like in this map, which is fire data, it's a little bit hard to see. You see, red pixels both in green areas and in blue areas and indigenous lands. But once you create an artificial control group for each of those protected areas, then you can create a graph like this. Here we have on the x-axis the counterfactual. So on the x-axis is the deforestation that we observed on those parcels that were matched. On the y-axis is what was actually observed in the protected area. So if all the matching worked well and the assumptions are correct, then every point that you see here that is below that diagonal has reduced deforestation. Okay, great. So we have reduced deforestation for most of them. But we also see a pattern in which areas seem to be particularly effective at areas of higher deforestation pressure. And these are here the indigenous lands. So what we saw is the indigenous lands seem to have been able to withstand that deforestation pressure more than the other types of protected areas. And we see that the strict protected areas have lower deforestation on average for in controlling for this pressure than the sustainable use areas. So that was interesting, and many people found that result interesting. Still my most cited paper, but there are a few concerns with it too. One is that, whether the things that we controlled for actually created the similarity that I'm talking about. We'll get there. The other one is that some of those areas were pretty old, actually. They had existed a while ago. So we were not actually necessarily matching them at the time that they were conserved, but the time that they were actually created, where we would expect the causal impact to start, had been a little bit in the past. So there are modifications of this algorithms. There are, we continuously work on them, and others have been working on them for a while. One example that I'm also relatively familiar with is a study that we did on the Argentinian forest law in the Chaco. So the Chaco, you might remember the satellite imagery, that time series that I showed earlier, is a deforestation frontier that has been deforested very quickly over the past 2 decades. And in 2007, Argentina said, okay, well, all the provinces have to zone their lands into areas where there's no deforestation allowed and others where it is allowed. and others which are sustainable use areas. So the question is, did that law make a difference? Many people said no, there's plenty of illegal deforestation happening, and sometimes you see deforestation even go up for reasons of commodity prices, etc. So by using both the matching method, like we tried to find parcels that were similar, that were inside different zones, but then because what you see is the zones are very clumpy. And so it is very hard to actually make them similar. So essentially the comparability is just not very high between some of those zones. Well, if you then add a time series aspect, a method that's called differences in differences, so it's essentially you see how those things changed over time between the treatment and the control group, then you strengthen your inference. And one thing that we assume happened at the Chaco is that yes, the law did make a difference, at least in some locations, but it's actually quite hard to see if you don't use these kind of methods. Okay, one more example. I mentioned that I would talk about Boston. In the United States, land conservation happens in very different ways than down there. I don't remember, okay, there was the Northwest Forest Plan, but since then I don't remember like a massive law that has suddenly protected vast amounts of forest in the long run. What happens in the States is that you have thousands, tens of thousands, hundreds of thousands parcel level voluntary transactions, land acquisitions, easements, and they don't happen like suddenly all at once. They happen over the course of decades. So one thing we did was we looked at an example in Massachusetts, 220,000 parcels, 6,600 of which had been protected in like the time period that we look at in this analysis, 85 to 2006. And then we tried to quantify both the impacts, how much of a difference was there between protected parcels and matched unprotected parcels. But we also looked at a second piece, which is spillovers. Here's a concern that people often have with that parcel level approach. And that is, if you protect this parcel, people will know that it's protected and they will want to be next to it. And perhaps you get more development next to the parcel. You might both displace it, but also attract the development. So if that is true, then parcels that have experienced protection in their neighborhood, they should have different deforestation rates or development rates than parcels that are otherwise similar, but that did not experience this kind of change, this kind of nearby change. So we tried to look at both in this analysis. And one of the challenges in here was that we had to match each of those parcels, not only in space, but also in time. So essentially we had to check that every parcel was matched to its twin parcel at the same year that this one was protected or right before. One thing that's really important about matching, because we're trying to reconstruct this idea of an experiment, is we try to match them before something even happened. So in Massachusetts, we said, well, it seems like what we're observing is that, yes, protection did reduce forest loss. It did also reduce development, which is something we could look at for the first time because we had a multi-class land cover change layer, such as the ones I talked about earlier. So not only forest, non-forest, but also development, agriculture, wetland, etc. And so we saw, okay, both that there were reductions, but also there were no spillovers. We couldn't find spillovers in Massachusetts, which is different from what other people had found earlier in the literature. So we're trying to now scale this up to the US and see whether that's true generally or whether this is just a Massachusetts phenomenon. But here's another thing that I think is important to keep in mind. In the differences in threat, the differences in impact are not that much driven by differences in what happens to the parcel that is protected, or the level of deforestation that you observe on the parcel that is protected. In this graph here, so I realize I missed explaining those graphs. So black here, those black thick bars, and all of this in previous graphs, are the level of deforestation on the protected parcels. And then the ones that are on the other side of the graph, this is the level of deforestation on the controls. That's the counterfactual, that we estimate would have happened if it hadn't been protected, right? So what you see here is that the level of deforestation development you actually see on the parcel is pretty similar, but the level of threat really varied. So parcels that were far away from cities, high travel time, had very little impact compared to parcels that were close to cities. And similar to those that had high median income had higher impacts than those at low median income, but mostly because the threat was different. All right. So before I move on to the next topic, and I will try to go a little bit quicker here, I want to highlight that I want to give you a piece that you should always, let's say a question that you should always ask those kind of studies. And that's like similarity in terms of what? You know, in which ways do you, on what basis do you establish the similarity? Right? Here are the variables that we used in the studies that I just showed. They're different in each of those studies. In each of those cases, you have to craft an argument of why you believe this is a variable that both affects the likelihood of protection and the likelihood that you would have observed this land cover change. And so there are those variables that, so essentially you have to think about, you have to ask this question. If you have a pair of a place, let's say that where someone said, I will accept a payment for environmental service program to not cut down my forest. And another one that you say is similar, but where the person didn't choose to do that. In which ways might those two be different? In ways that you might not have controlled for. Right, so we usually control for variables for which we have data, or for which we can get large scale data. But very often you might have unobserved variables for which you don't have data. And that affects the strength of your causal inference. So that's the question you can ask any of those studies. You know, like, to which extent do you actually think the matching removed that bias? And once you start asking that question, which is, I think, the big elephant in the room that sometimes gets swept a little bit under the rug in those studies, you know, you can come up with many of those. You know, landowners might have different preferences. Some really like the environment, others don't. So, oh, you missed the local regulations. You know, there was this rule over here. This town had a land use zoning, this other one didn't. Oh, it's different people, different demographic composition, different income, different race. You might have missed certain natural amenities. You might have disamenities, et cetera, et cetera. So how can we deal with that? Well, yes, you can have methodological ways to deal with it, or you just say, well, I'm not entirely sure, but here's the best thing we can do. One way how we're trying to improve this kind of work in my research group is to just try to get data on all of that, to be able to control for it. And so here's where I introduce the system that we're building at Boston University, which I call PLACES, the Private Land Conservation Evidence System, which tries to aggregate all this information, or as much information as we can get our hands on, to the parcel. So that for each of the 140 million properties that we currently have in the database, which covers about 98% of the country, we know what the tax assessor says in terms of what attributes that parcel has that affect its value. We have transaction data. We then use the parcel polygons, link it, extract information on natural features, infrastructure. With satellite data, we get building footprints, we get land cover change, we can get neighborhood characteristics from census data, from spatial proximity indicators. And then with that, we add conservation information about who did what and when, for what price, with what mechanism. And the hope is that with that, we can improve our understanding of these very complex and very nuanced transactions, and start to be able to estimate the impact. PLACES, by the way, also includes a flood hazard component, which I'm not directly involved with. That's my PhD student building it out, but we're actually right now also using it for hedonic analysis of flood hazard. So this work is happening. The data is massive. If you're interested in doing this kind of work, please reach out. If you want to understand the impact of a certain intervention in the US location, please reach out. We definitely cannot do all this work ourselves. But I want to briefly get to the last point, which is, as we're building this knowledge on how much of a difference certain interventions make, we learn that areas that are very far away from threat should be avoided. Well, not should be avoided, but we should consider the fact that they don't do much. If you buy those, if you protect those, you don't make that much of a difference than if you buy or protect a property that's very close to development pressure. Right. So the idea is, okay, we should protect land that's very threatened. But that's also not correct. Land that's very threatened is usually very costly. Land that's very not threatened is usually very cheap. So unless we get cost into that equation too, we still cannot provide advice on how to allocate funding. Now, because we already had all this data in the system, why don't you use this data that we have and try to get at cost? The impetus for trying to use this data to get at high resolution cost estimates comes from a person who spoke earlier. Hi, Paul. He looked at several large-scale conservation planning studies, and I think, Paul, you might correct me there, there were about 30 or so that you looked at, and you said these are studies that are well-cited, that people know well, but there's very little attention given to the cost that conservation organizations actually face. There's a heavy reliance on proxies. And that's often normal. Many people that do conservation planning are not economists. The idea that you have interdisciplinary teams such as those involved in this work, and such as those actually here on the call, with Charles being an economist, Paul being a conservation biologist, and both working together on related issues. That's not something that has always happened. That's something that's really exciting now. So many of those early studies, many large-scale studies use some kind of proxy, often county-level proxies, for what a conservation intervention costs. Many of those, if you want to do an analysis for the entire country, then at this point, or until recently, you could only really get at county-level estimates. And there are a few, and if you look at, here are 3 relevant ones, and if you look at them, they have relatively similar spatial patterns. But you see, for instance, you have locations in the West here, where in particular this, I believe this is Riverside County in California, or the one below. Anyway, there are counties where some of the land is very, very expensive, some of the land is very, very cheap, and you don't get that heterogeneity captured. So if you just take a off-the-shelf machine learning algorithm, for each county, you pull the sales data, and with all the information that I just showed you, you pull that together. You filter out the sales. You add some filters to make sure that the sales reflect the value of the land. You use an extremely randomized tree regressor to predict the sales price based on a bunch, more than 24 different property characteristics, and then you use that model to just extrapolate to predict sales prices for all the properties. Then you can get from something that looks like this to something that looks like this. And this is a map that is not yet published. It's currently in the publication process, but you're actually the first to see this map publicly. So this is, to my knowledge, the first high resolution map of estimated land value for the United States. And I have a little 3D component here as well that I can briefly share. So this is how the data looks like. You see, of course, cities are expensive, and those expensive cities are actually missing in most of the proxies that we're looking at. Blue here is public land, brown is Native American land, and the color shading, then I assume you can interpret that this is cheap. Here's the cheap lands of the desert and the dry plains. And then as you get close to cities, it gets very expensive, and it gets very expensive indeed, right? So if you're looking here at Washington, New York, this little thing here, that's the Hamptons. They're also expensive, as some of you might know. Anyway, so you have suddenly a very high resolution data set for estimated land value. And then the question is, how closely does that correspond to the cost of conservation? We looked at 4,000 transactions where a governmental organization was involved in acquiring land for conservation. And we find that So here, up here are 4 proxies that were used in the literature. These 2 here are tax assessor estimates. And then these 2 here are our 2 model results from the one I just showed you. And what it looks like is that we have with a simple regression, the R² value of a simple regression, we get a ton more explanatory power of how expensive conservation, or at least land acquisitions, actually are than in previous proxies. All right, in the interest of time, I will just skip over some of the things that we found with respect to prior studies, but perhaps for the audience in this group, in this call, I want to highlight that we did reproduce a recent study that tried to look at the extent to which these new cost layers will affect conservation recommendations. And what you see here is a run of a conservation optimization model, and the pink areas are areas that with the new cost data, the model said shouldn't be protected anymore, and the green ones are those that are added to the network. And if we just look at Knoxville, we see that apparently, if those cost data are correct, and if we're fine with the assumptions of the model, then we should not protect Knoxville. We should perhaps also not put that much effort into the North Carolina mountains. So if we could freely allocate money for conservation, there are parts, north of Knoxville that might be a better deal for conservation. This is all very preliminary. No, there's no threat in here, but these are things that you can start doing if you have high resolution cost data. All right, let's step back a little bit. Where were we? I said we want to understand what causal impact interventions make and what they will cost. Both are questions that people have grappled with for a long time. In both cases, there are definitely alternative ways at finding answers to those questions. But I think that right now we have really, really we're living in a really, really fascinating time to make progress on some of those methods and building the evidence base, the global evidence base for causal impact of conservation interventions. And so whether you want to talk about time series algorithms for tracking land cover change, about quasi-experimental methods for causal inference, or about large-scale synthesis of rich property data, I'd be happy to talk with you. We're a group that is excited to, collaborate, to work with others, to allow to create data access for other researchers that want to ask questions that they're interested in. So if you're interested in this kind of work and want to learn more, feel free to reach out. And with that, I would like to say thank you. And if you have any questions, let me know.
Thank you, Christoph. So we've got 63 people here today, and we've got quite a few questions in the chat box. This will give everyone a chance to kind of go through and type those into the chat box. Any questions that you might have, and then I'll try to pull those together as much as possible. Paul, if you see something you want to add too, then go ahead. But I'm noticing a couple of questions around this question of, one, the 3D map of cost data looks really cool. And then the question is, that's all well and good, you did a great job, now make it change over time, right? And so, yeah, we're not satisfied, Christoph. We need this to change over time. And so we're thinking through what are the next steps to getting this to change over time, obviously recognizing that lots of these places that are showing kind of low threat levels may be facing increasing threat in the future, and how might threat patterns in the past kind of help us think through what this might look like as if we were to put some sort of time clock on this and let it tick through like some of your satellite images did.
Oh yeah, that's great. Wonderful. I like that question. And actually that's very close to a question that the reviewer asked. So I'm happy to try to take a stab at an answer. So first, yes, well observed. This is cross-sectional data. Actually, so the sales are from 2000 to 2019, and the values are predicted for 2010. Why for 2010? Because the year of sale is not only incorporated as obviously to adjust, to inflate the prices, to get to real prices, but also because, you know, there was a financial crisis during that time. And definitely land values changed over time. So yes, this is a cross-sectional data set. Mostly the big advance that it offers is over, you know, the previous similarly cross-sectional proxies. But how do we deal with time? The simple answer is we haven't done that yet. Algorithms that predict in time are a very active area of research. I'm not sure, perhaps some of you have noticed that Zillow, the real estate company that actually gave us, made the tax assessor data and transaction data available that this map is based on, they also separately had a $1 million competition for data scientists that wanted to develop predictive models of property prices. So this is an active area of research. And so what a model that tries to predict in time would have to be able to do is to be trained on, let's say, the whole model selection and validation would have to be based on its predictive performance in time. And this is not what we did here. So there are, of course, ways to do that. And I think that's actually a natural next step. But there's definitely also this aspect of unpredictability and spatial dependency. One, prices will change as the result of external policies. Let's say agricultural land suddenly became more valuable when biomass subsidies occurred. That's something, you know, if you foresee it, okay, then you can try to model it. If you don't, then it's just missing. Similarly, how cities develop, you know, suddenly, you know, there's a large development project in one corner in one direction around the city center, and that's where the prices go up. Or the extension of a metro line in Boston does the same. So those are things that you either explicitly have to, you know, model and address, or you cannot predict them. If the person or the people asking these questions are interested in playing with the data in order to create predictive models, I would be very happy to collaborate.
Oh, muted. Sorry. So there's a couple of other questions here kind of in this area of the matching technique. The very, very cool stuff using quasi-experimental data. As economists, we've used this for a while, kind of cheating and stealing from the medical community. The matching thing is always the hard part, right? It's always kind of the figuring out what is the comparable parcels in terms of what, right? So we had a lot of questions around the matching and how that works. One, I think it was a basic question about just how does the matching that you're currently doing just differ from using just a basic linear probability model of including a whole bunch of potential factors in there, like income, land type, and things like that. And then probably related to that is this idea of how does this big data set places kind of change how you think about doing the matching? And I imagine those questions are somewhat related.
Those are fantastic questions, absolutely. All right, so let me see. Okay, first, how does it work? There are multiple matching techniques, but perhaps the important thing to retain is that you do end up having to choose a single distance indicator that gives you similarity, a measure of similarity. So the question is, how do you compute that distance indicator? Two very popular and different methods to do matching are propensity score matching or covariate matching, Mahalanobis distance matching. In the case of propensity score matching, you do something very similar to what was just described. You develop a probability model of the parcel being conserved, and then you match based on that. In the case of Mahalanobis matching, what you essentially do is you compute the distance variable is something that is similar to a Euclidean distance. So imagine a multidimensional covariate space, and you map all your points into that space, and you try to find the closest neighbor. Mahalanobis distance also accounts for covariation, but that's another technical detail. But the point is, you always need to define a distance. I think there's a really interesting paper published by Ho 2007, which says what exact indicator you match on that's not what you focus on, what you should be focusing on. What you should be focusing on is how well balanced is the sample that you get. So whether you use one of those matching methods or the other one, that's just a way to get you somewhere. And that somewhere is to which extent do you actually have similarities in those two groups? And again, then you can say, how would you establish similarities? Usually people look at the mean differences between those two groups in all the different covariates. And if one pops out as being particularly bad, then you try to control that or put additional tolerances on the matching. So let's say there are a lot of details to the method, and there are other methods coming out where you can match exact, where you block the whole sample into different bins and then just compare those different bins. This is called coarsened exact matching, also very, very interesting. Let's see. I think I got a little bit lost in my technical detail. As the analyst, the nice thing is that in theory, you could do the matching until you are satisfied with the balance. And usually you also have to count how many of the parcels do I still have after matching, because some might just be too incomparable. And once you're done and you feel this is a good sample, now I really feel balance is good, now you look at the impact. Right? So you avoid kind of that step of looking at the results. Oh, I don't like those results. I don't like that impact result. I don't believe it. And then trying to redo your model. No, you first try to get the balance right. And then when you're happy with that, you look at the impact. So I'm not sure whether I answered all of the questions, but feel free to reformulate or reiterate them, and I'd be happy to get there.
And so I think if the follow-up question would be, if you were to use kind of, how does this new big data set places change how you might do your matching technique? And I suppose that there's probably some aspect of historically we've had to define what similar, the factors that might determine similarity. Whereas with a big data set, maybe you can let the computer and you can let machine learning define what determines similarity. But I have a question kind of talking about how does that change your thinking about doing these experimental methods?
Great question. And I will admit that my answer will be very incomplete. I think there are people working in this area that will have a lot better thoughts on this than I have. But a few thoughts. One, the reason why this data set exists is that I really didn't want to create those data sets again every time I'm interested in an analysis. Right? So now essentially one of the reasons why this data set exists is now we have all those covariates. They're all linked. Like we can put any kind of research project on top of that where we need those kind of variables. Right? So there are so many different research conservation interventions and types of things that happen to those parcels that being able to just easily control for the things that we consider potentially being important allows us to do very quick robustness checks, for example. I would generally caution about the idea that we can just have the computer figure out the details. The idea of what constitutes similarity has to come from your knowledge of the case, has to come from theory, has to be argued. Let's say, some of those variables might get really important when a certain choice is made. Let's say, I don't know whether I have particularly good examples, but for some interventions, income might matter. For some interventions, it might really matter whether a property is next to a lake or not. For some interventions, it might really matter whether the soil is fertile or not. And for others, it might not. And so at least the way how I was trained is, you have to come up with the reasons for why you control for certain things. And then you can still add statistical tests. You can still, run your probabilistic models of, what determines protection and what determines the outcome on unprotected land separately, and see whether the statistical models highlight that there are other attributes that might be important. But I feel you need to negotiate with your actual real understanding of the case. And I caution against missing that step. Although I'm definitely doing that as well.
So then maybe the big data sets do not change necessarily how you perform the matching or how well the matching occurs that much?
Well, I think one opportunity that it provides is to test the robustness of matching results to a different weighing of covariates or to missing parameters. So, for example, in publishing those studies, sometimes I get a reviewer who has done a similar analysis, and the reviewer says, in the Amazon paper, right? So I got a reviewer who had done similar work and said, well, you didn't control for distance to the edge of the forest. That seems really important to me because the distance to the cities is not enough. You also have to control, like, how close is it to a forest? And we knew that this was important in our study. Okay, great. So we added it, right? But that is like an interaction. Like, either you get that feedback from a reviewer or you don't. So understanding, which of variables you can drop or not in certain circumstances, which ones really drive the results, is, I think, something that that we should be doing more and more if we start publishing those studies. So I feel the stakes for building confidence in this kind of work are high, but I think also with more data we can at least rule out or test for the necessity to include certain parameters. One more thing, matching usually is difficult when you use tons of dimensions. When you have a very, very multidimensional data set, let's say if you use 140 data points, depending on what method you use, but definitely with the propensity score matching and definitely with the covariate matching, variables that are not important might essentially pull the comparability to them and away from the variables that are important. So weighing behind the scenes is still something to be cognizant of.
And are you aware of any efforts to kind of do something similar to places in other locations, Brazil, Indonesia, places where there might actually be more development pressure coming in?
Also a fantastic question, and I do have to admit that I never thought I would be working on the United States until I got really obsessed with data and with trying to do this kind of work with in locations where the data is very rich, in particular the data on properties, property value, and property level indicators. It is very, okay, in many tropical locations in many high biodiversity locations, this data does not exist. I personally know it from certain locations in Colombia because we have tried many countries are, let's say, digital parcel maps are becoming more and more commonplace. But the data linked to those digital parcels is still rare in many tropical locations, and in particular in deforestation frontiers. The flip side of that would be countries where the data exists, but it's difficult to access them for privacy reasons. So an advisor I had when I was still back in Germany in an environmental economics department mentioned that he had been trying to get sales data for German properties for a long time and was unable to because of privacy concerns. So to some extent, what we're doing here might be, let's say, the opportunity to develop those methods might be particularly easily available in this country. Although those social mechanisms, like the properties exist elsewhere, property boundaries exist, sales exist, just whether they're stored and to which extent they're accessible varies enormously. And even in this country they do. There are several states that have so-called no disclosure states. And I haven't showed the map of the distribution of my sales data, but if you go to Montana, we essentially have almost no information. And similar to, I believe, Kansas and in other non-disclosure states, data is very thin. Texas and Alabama, I believe, or Mississippi. Anyway, so even in the States, there's enormous heterogeneity in the availability of this data.
So thank you, Zillow, is what you're saying, right?
I'm absolutely thanking Zillow. I'm not getting a commission for here, but I think it's absolutely wonderful that they made this data available for academic and governmental, let's say, users, so essentially for non-commercial users. There's an enormous interest. There's a lot of research happening on working with the Zillow dataset. And if you're considering getting Z-Tracks access, I highly recommend doing so. And I do highly recommend linking it to parcel data because the coordinates that you get in that dataset in many locations are incorrect. That's one thing that we found out. Separate issue, but yes, thank you, Zillow.
So we have another question here about kind of taking these techniques that you're talking about and transferring them to other applications. And so you can absolutely punt on this and say that I haven't thought about this and this is not in my wheelhouse. But how well would these techniques work if we were to take them and look at things like managing water systems? So bodies of water, rivers, conservation in the aquatic domain instead of the terrestrial domain.
Yeah, no, that is a really important question, and one I'm actually asking myself frequently without having an answer. So I do not have a necessarily satisfactory answer, but I have a few thoughts perhaps that I could share. I think one of the issues is that okay, like first an area where I think there is a link. I think there is a link definitely when you talk about relationships between land cover and water systems. So to the extent that we can talk about, for instance, in Colombia, much of the land acquisitions that happen for conservation happen specifically to conserve water resources. So to the extent that we can say, okay, we can talk about the relationship between where forests have been conserved or have been created and where the water flows and how the water flows, we might start building models about how that might have affected the conditions of the water system. And there are, of course, many efforts to try then to optimally allocate efforts to protect land in order to conserve water systems. Water systems, well, I haven't worked much with them, but what I do remember from, let's say for me, because of the flow properties of water and the many observed, unobserved and unobservable movements of organisms within the water, and also because of the fact that we do not necessarily have these like fine scale institutional allocations to water that we do have on the terrestrial realm, such as private properties. I think that, yeah, I have not yet found a opportunity that I would excitedly jump on to do this kind of work in water systems. But perhaps, if the person asking the question has a more specific idea, I'd be happy to elaborate. And just because there was a question about techniques, I mean, those techniques, as another commenter mentioned, they have been around for a long time, right? So in a way, I was surprised that no one has just thrown a machine learning algorithm at sales data and seen whether they can create a land cost map. Thank you for leaving that space open in that sense. And similarly, as someone else commented, these matching techniques, I wasn't even aware that economists stole them from health. But we definitely say we stole them from economists, or rather economists brought them into land cover change, into land cover analyses. So I think there's an ample borrowing of techniques, and I do have the sense that often the environment policy realm sees them relatively late, and so we're kind of we're kind of borrowing a lot from other fields that have a lot more experience with those methods, perhaps partially because they have much higher stakes, such as in the health sector, or more immediate stakes.
So I think there's one kind of question that gets onto this and that addresses some other questions that have popped up as this conversation has gone on, is kind of how this evolution has happened, right? I mean, I say the economists stole these things from public health and from health in general. Of course, the thing that the economists were worried about was we can't do randomized controlled trials, right? We don't have that ability to do these things necessarily when we're talking about policies and economic impacts, things like this. So part of it has been developing how do you get around that non-randomization component that you were talking about, and tools and techniques for doing that. And I think over time, there's been this question about, well, are you doing it to the extent that we can really say that what you're identifying is causality? And I know that at least early on in The Economist, there was a lot of pushback against that. Economists now are sort of on board with this idea that you can identify causality through these types of methods, even though it's not completely random. We've gotten around it and we've accepted it and whatnot. I'm wondering if that same concern about, does the matching techniques you're doing here, does it actually identify causality? Does that show up still in your field? Is that something that maybe people are trying to get more comfortable with over time? Because as you said, the randomization process is obviously the elephant in the room. It's not completely random, and so it's how comfortable are you with that?
Yeah, no, that's absolutely correct. How comfortable am I with that?
Or Or maybe
I'm uncomfortable with it. I am actually uncomfortable with it. So a few thoughts. Randomization is also moving into fields that classically haven't used that much randomization. If you just look at who won the Memorial Nobel Prize in Economics, it was people that were last year. It was people who pushed forward randomization in development, for example, which had been neglected as a field in which you could do randomization for a long time. Randomization is happening in environmental policy. There's just a lot less of it. So I think things that would be really instructive to do, obviously not globally, but certainly in locations where we could really learn something about those interventions in a generalizable way, would be coupled research projects where you do have randomization, and then you try to reproduce them with matching, and then you start getting a sense of what you're missing, where, yeah, I mean that I think would be one area of research that would be quite interesting. I think the more that I work on this, the more I feel one thing that is not sufficiently said is just where do we feel the boundaries of this kind of research is. Essentially to like control ourselves a little bit in terms of how much you can actually say with those methods. And I think so one work that I think, well, one direction of work that would be quite interesting is just to try to think harder about this issue of incomparability. Especially in conservation, many of the lands that are protected are just very, very unique lands. Like you do not find another Yellowstone. You do not find another Yosemite. You do not find another Sierra Nevada de Santa Marta, the most irreplaceable park in the world for threatened species. So it's very hard to do those large, or it's hard to justify those very large scale comparisons where you're really comparing things that are very, very different to each other. But to the extent that we have interventions that happen in large numbers in landscapes where you have it's only small fractions of locations that receive a certain treatment, and you have a large number of controls that you compare it to, you do get a lot of this comparability. That's also one of the reasons why I work currently on these very small scale transactions, because you always find plenty of parcels that haven't been protected. So I think directions of research that would be valuable to pursue are both, trying to figure out the limits on this kind of work and learning more about the biases of quasi-experimental methods. I'm actually wondering how familiar we are with the literature in economics. You say they have brought that in, or that there was critique and pushback. Now it's accepted, but the concern is, I guess, still there.
Well, I would say less so now. I think what I hear more of is economists going and presenting and claiming or calling what they would consider causality, and then they get pushback from other disciplines who have not yet done these methods, or maybe haven't thought about them as much, and I'm not really sure why, but a lot of times we'll get more pushback from the fact that it is what we are establishing as causality from these other disciplines. I think within the economics world, questions about causality get reframed as questions about the validity of your instrumental variable and things like this, right? And so we're still concerned about it, but we don't have a concern about using the method itself. It's more of, do you have it's back to the matching. How well did you do the matching part, right?
Yeah, and it's I think I completely agree. It definitely has to do both with having more people educated about what those methods actually do, and then perhaps seeing in the context of quasi-experimental work the word causality not as much as a final claim, but rather as a direction and as an admission that this is what you're after, right? So I think I feel there's a lot of researchers who say, well, obviously we cannot establish causality, so we are not going to do that. But then you find in the same papers arguments that sound very much like a causal argument. And so being both transparent about the fact that you're trying to get at causality, but that you might not quite get there, and that you're aware of the circumstances, and having readers that are able to understand that, I think that's a valuable direction to go, because you still can do those analyses. I think those analyses are still very valuable, and let's say if you come up with a matching analysis, you say, see, these two groups are comparable on all those aspects. Now tell me what they're not comparable on. Then, you know, essentially you have a strong argument. You don't have the final word. I don't think we will have final words in this kind of work, but you have at least something that is quite interesting. And one more point. I think one thing that I find quite exciting about the matching work is how explicit you actually have to be or can be about what your control group is. Right? So their matching is related to, you know, regression analyses and, you know, putting dummies into regression and trying to infer the impact like that. And very often people that are not familiar with the details or that have not had, let's say, trainings in econometrics will have a very hard time interpreting those results. But if you do matching, you end up with a control group that you can map. You can give that to policymakers. The policymakers who want to make the decisions based on your analysis, that probably know the landscape context better than you do. And they can say, well, you matched things here that are completely uncomparable, and here's why. And then you have a covariate that you can start considering, which is something that I think you don't get with other methods. Like, you can be very explicit about what things you're actually comparing to, just by putting them in a map and showing what things have been matched.
Christoph, you've been a trooper. There's a lot of questions, a lot of technical issues that you were entertaining us with. So I think I'm going to cut it here and give you a break. Thanks everyone for all the great questions and posted in the chat box. Thanks to Christoph for doing this, and join me in thanking Christoph one more time.